What if I told you that some of the most breathtaking light shows on Earth happen not in cities or theaters, but in the cold, thin air high above our heads, created by something as simple as ice crystals? Picture this. You're walking on a crisp winter morning when you notice something strange happening around the sun. Two bright spots of light appear on either side, glowing with rainbow colors. Or maybe you've seen it at night, a perfect circle of light surrounding the moon, like a celestial crown. These aren't mirages or tricks of the mind. They're real atmospheric phenomena called sundogs and moon halos, and they reveal secrets about the invisible architecture of our sky. Both of these stunning displays share the same origin story, one that begins with ice crystals floating miles above the Earth's surface. But how can something as delicate as frozen water create such precise and beautiful patterns in the sky? The answer lies in the hidden geometry of light itself. To understand what creates these celestial displays, we need to look at the conditions that make them possible. Sundogs and moon halos don't appear on just any day. They require very specific atmospheric setups, the kind that occur when the air high above us is filled with countless tiny, six-sided ice crystals. These crystals form in cirrus clouds, those wispy, feathery clouds that look like brushed strokes of white paint across the blue canvas of the sky. What's fascinating is that these ice crystals aren't randomly oriented. As they float downward, air resistance causes them to align in particular ways, some floating like falling leaves, others like spinning plates. This organization is what turns ordinary sunlight or moonlight into extraordinary optical art now. Let's dive into exactly how these crystals transform light into the patterns we see. When light enters a hexagonal ice crystal, it doesn't just pass through, it gets redirected, split, and sometimes even sent back out at precise angles. This is where the magic of physics takes over. For sundogs, the key players are plate-shaped crystals that float horizontally as they descend. When sunlight hits these flat, six-sided plates, it enters through one side face and exits through another face that's rotated 60 degrees from the first. This double refraction creates those bright spots you see at 22 degrees to the left and right of the sun. But why the rainbow colors? Because different wavelengths of light bend at slightly different angles, separating white sunlight into its component colors, just like a prism. The most intense sundogs appear when the sun is low on the horizon, making the angle perfect for this light show. To unfold moon halos work on similar principles, but involve a different cast of crystal characters. Instead of flat plates, halos typically form through randomly oriented column-shaped crystals. These tiny hexagonal pillars tumble through the air in all directions. When moonlight enters through one side of these columns and exits through another, it gets bent at exactly 22 degrees, creating that perfect circle around the moon. What's remarkable is that this 22-degree measurement appears again and again in atmospheric optics because of the specific geometry of hexagonal crystals. The ice essentially acts as nature's precision optical instrument, consistently bending light at this magical angle, whether it comes from the sun or moon. Sometimes you might even see faint colors in these halos, with red appearing on the inside of the circle and blue on the outside. A subtle reminder that we are witnessing light being taken apart and put back together by invisible hands of ice. But the story doesn't end with simple circles and spots. Under the right conditions, These basic phenomena can evolve into even more complex displays. When the atmosphere contains multiple layers of ice crystals with different shapes and orientations, you might witness tangent arcs touching the halos or parhelic circles stretching across the sky. There are even rare occurrences like the circumzenithal arc, often called the smile in the sky, which appears as an upside-down rainbow high above the sun. What all these variations have in common is their dependence on the precise alignment of ice crystals. Even slight changes in temperature, humidity, or wind patterns can transform one type of display into another, making each occurrence unique to that particular moment in the sky's ever-changing theater. What's truly fascinating is that people have been observing and interpreting these phenomena for thousands of years. Before we understood the physics, sundogs and halos were often seen as omens or divine messages. Ancient Greek philosophers wrote about them, medieval artists included them in paintings as heavenly signs, and Norse legends interpreted them as glimpses into other realms. Even today, when we know exactly how they form, there's still something mystical about watching light rearrange itself according to ancient geometric rules. These displays connect us to generations of skywatchers who looked up with the same wonder, even if they understood the mechanisms differently. The beauty of sundogs and moon halos isn't just in their appearance, it's in what they reveal about our atmosphere. Every time you see one, you're essentially viewing a map of conditions in the upper air. Those ice crystals tell you about temperatures far above the ground, about wind patterns you can't feel, about moisture content in regions we can't reach. They're natural instruments that make the invisible visible, using light as their measurement tool. And perhaps most importantly, they remind us that wonder doesn't require special equipment or distant travel. It's often waiting right above us, in the ordinary sky, on days when the conditions align to turn ice and light into magic. Have you ever witnessed a sundog or moon halo? Share your experience in the comments below. We'd love to hear about the most incredible sky phenomenon you've ever seen.